In the summer of 1887, on a stone-walled farm in the tomato country outside Acerra, in southern Italy, the harvest was failing. Half the fruit on the vine was rotting before it could ripen, black sunken wounds spreading across the bottoms of the tomatoes. The year's food disappearing in front of the women who grew it. They didn't call a chemist. There were no chemists for them to call. They did what their mothers had done, and their mothers before them. They crushed a bowl of eggshells from the morning's bread making. They covered the shells with the cheap red wine vinegar that lived in every Italian pantry. They sealed the bowl with a cloth. And they waited 4 days. By the end of that summer, the tomatoes from those farms were the only ones in the region that didn't crack. That preparation, eggshells, vinegar, 4 days, has been independently rediscovered on 3 continents in the last 2 centuries. It has been studied at the University of Hawaii's College of Tropical Agriculture. It has been codified into Korean natural farming under the name Water-Soluble Calcium. And it is the exact same chemistry that bottled calcium booster products at every garden center in America are now selling back to you for $30 a jar, using the eggshells you threw away yesterday morning. This is the story of what blossom end rot actually is, why most of the CalMag bottles on the shelf can't fix it, and exactly how to make this preparation tonight in your own kitchen. Stick around, because the part that almost every gardener gets wrong isn't the recipe. It's when you spray it. Get the timing wrong, and you'll burn the leaves of the plant you're trying to save. Get it right, and 7 days from now, the next round of fruit on those plants will set without a single black spot. Have you ever walked out to your tomato bed in late June, coffee in your hand, and seen it? That black, sunken patch on the bottom of a fruit that wasn't there yesterday. The skin caved in. The flesh underneath gone leathery and dark. A whole tomato. A tomato you watched form, that you tied up, that you watered through a hot week, already finished, already a loss, before it ever got a chance to turn red. That has a name. Plant pathologists call it blossom end rot. Gardeners call it heartbreak. And here is what makes it cruel. It doesn't happen to one fruit. It moves through the whole plant. The first one you find is rarely the last one you'll find. By the time you spot it, the next 4 or 5 tomatoes already developing on that vine have usually already decided they're going the same way. You walked out to that bed expecting an August harvest. What you're looking at is a failed season. The story you've probably been told about why it happened. The story your local garden center will tell you. The story written on the back of the $30 bottle they want to sell you. Is only half right. And the half that's missing is the half that actually matters. For most of the 20th century, the explanation was straightforward. Blossom end rot, they told you, is a calcium deficiency. The cure was to water more, mulch, and add lime. Blossom end rot really is a calcium problem. Watering inconsistently really does make it worse. Mulching really does help. The bottles really do contain calcium. It was a reasonable story. It just happened to be only half right. Because what nobody at the garden center will tell you, what's printed nowhere on the back of that $30 bottle, is that most of the calcium you put on a tomato plant doesn't actually reach the fruit during the 10 days that decide whether it will rot. Tomatoes don't develop rot because there isn't enough calcium in your soil. They develop rot because there isn't enough calcium available to the fruit during a very specific window, the 10 days between when the flower drops and when the green fruit reaches the size of a marble. Miss that window with available calcium, and no amount of late-stage spraying will save the fruit. By the time you see the black spot, the cellular decision has already been made. Ground limestone, the thing your extension service recommends, the thing you tilled into your bed last fall, takes between 6 months and 3 years to break down into a form that plant roots can actually absorb. 6 months minimum, sometimes longer. The CalMag bottle is faster, but the calcium has to be pulled up by roots and moved through the vascular system, competing with every other tissue. Leaves get the calcium first. The developing fruit hanging off in a corner of the plant gets whatever is left over, which during a hot week with inconsistent water is nothing. That is the actual mechanism of blossom end rot. Not a deficiency, a distribution failure. Solving it requires getting calcium directly to the fruit, not to the soil, in a form the fruit can absorb on contact during the 10-day window that decides everything. For most of agricultural history, no commercial product could do that. But a Korean rice farmer figured it out in 1965, by accident in a clay jar, using the eggshells from his breakfast. Cho was formally trained. He went to university. He studied chemistry. He was taught what every agronomy student in the world was taught in the 1950s, that plants need three things: nitrogen, phosphorus, potassium, that the soil is just a sponge to hold those minerals, and that any farmer's grandmother who insisted otherwise was indulging in superstition. He believed it for a while. And then he read a small book that had crossed the sea from Japan, The One Straw Revolution, by a philosopher-farmer named Masanobu Fukuoka, who had walked away from chemistry entirely and was producing rice yields that embarrassed every conventional paddy around him. Cho read the book. Something snapped into place, and in 1965, at the age of 30, he went home. He set up a small laboratory in a back room of his grandmother's storehouse. He began running careful, patient experiments. He cultured wild microbes from the leaf litter behind his village. He pressed plants for their juices. He fermented fish scraps. And one afternoon, looking at the empty eggshells his grandmother had left to dry on a kitchen rack, he ran an experiment. An experiment that, by every textbook he had read at university, should not have worked. He roasted the eggshells. He crushed them. He covered them with brown rice vinegar. He let the mixture sit in a clay jar for 2 weeks. And then he sprayed the resulting golden liquid onto the tomato plants his uncle was growing on a slope behind the house. 7 days later, every fruit on those plants was setting without rot. Cho called the preparation Water-Soluble Calcium. He published it. The Korean agricultural establishment dismissed it. The international community ignored it for 30 years. In 1966, Cho founded the Janong Natural Farming Institute outside Seoul, and across the next 4 decades he codified 7 complete fermented preparations that today are taught to farmers in more than 30 countries. Preparations that today are taught to farmers in more than 30 countries. And starting in the early 2000s, researchers at the University of Hawaii's College of Tropical Agriculture and Human Resources began publishing peer-reviewed studies, including in the journal Applied Soil Ecology, confirming that Cho's calcium preparation did exactly what he said it did. That the chemistry was real, that the bioavailability was real, that the field results were real. It took 130 years for the universities to catch up to the women of Acerra, but they finally did. What Cho discovered is that fermented eggshell calcium does 3 things at once, none of which a bag of ground limestone can do. First, the chemistry. Eggshells are 95% calcium carbonate, but combine it with vinegar and you get a reaction. The carbonate releases carbon dioxide and water. The calcium binds to the acetate, and what you're left with is calcium acetate dissolved in solution. Calcium acetate is something plants can absorb on contact, through the leaves, through the developing fruit skin. Immediately, no 6-month soil weathering required. Second, the absorption pathway. When you spray dissolved calcium acetate onto a tomato plant's leaves and developing fruit, the calcium enters the plant tissue directly through the stomata and the epidermis. It bypasses the root competition entirely. The calcium that lands on the developing fruit is the calcium that stays there. Third, the timing. Because the absorption is immediate, you can apply the preparation exactly when the plant needs the calcium, during the 10-day window that decides everything, instead of 6 months earlier and hoping the calendar lines up. 3 problems. 1 preparation. Made from kitchen waste. That is the entire chemistry. There is nothing else in the bottle. But there are 6 other homemade preparations in the same tradition that handle the rest of the season. A fermented plant juice for early leaf growth. A fish amino acid liquid for vegetative push. A lactic acid bacteria serum for waking up dead soil. 3 more besides. I've put all 7 recipes, exact ratios, exact timing, exact dilution rates, exact application windows, into a free PDF called Natural Farming Playbook. The link is pinned in the description below this video. Drop your email and it lands in your inbox in under 60 seconds. Use it as your full season playbook. Now, back to the eggshells. The bottled plant supplement market in the United States is worth several $1 billion a year. A single 16-ounce bottle of premium CalMag at most American garden centers retails between $22 and $34. A single 16-ounce bottle of homemade water-soluble calcium costs about 30 cents to make. The eggshells were free. They came out of your trash. The vinegar was $2.50 for an entire gallon, of which you used a cup. That's the math. 30 cents versus $30. 100-to-1 markup on a preparation a Korean grandmother could have made you while waiting for the kettle to boil. This is not a conspiracy. It is simpler than that. It is market logic. A product that cannot be patented cannot be marketed at scale. A product that cannot be marketed at scale will not get research funding. A product without research funding will not get recommended by extension programs because those programs are partly underwritten by industry grants. A product not recommended by extension will never reach the shelf at your local garden center. The chain runs by itself. Nobody at any point in it has to plot anything. The system simply forgets. And here is the punchline that most viewers will only catch if they're listening carefully. The eggshells in your trash this morning, combined with 30 cents of vinegar from your pantry, will produce a finished calcium preparation that is chemically identical to, and on the published peer-reviewed evidence, more bioavailable than, the bottle the garden center is selling back to you for $30. They take the shells from your trash and they sell them back to you for $30 a jar. That is the entire business model. That is the wall that has been built around your grandmother's clay jar. They take the shells from your trash and they sell them back to you for $30 a jar. That is the entire business model. That is the wall that has been built around your grandmother's clay jar. This is the entire program. 4 steps, about $1 in ingredients, 2 to 3 weeks of patient waiting, a full growing season of treated tomatoes. Step 1. Prepare the calcium source. Save the eggshells from 1 full week of breakfasts, somewhere between 10 and 15 shells. Rinse them under cool water and pull out any obvious membrane. Spread them on a baking sheet in a single layer. And roast them at 350 degrees Fahrenheit for 15 minutes. The shells will turn from white to a pale beige, sometimes with light browning at the edges. That's correct. The roasting drives off the organic membrane and lightly chars the calcium carbonate, which makes it dissolve in acid much faster. Take the cooled shells, drop them into a clean kitchen towel, and crush them with a rolling pin to roughly the texture of coarse sand. Not powder, not whole shells, coarse sand. This is the first place beginners fail. Do not skip the roasting. Raw eggshells will eventually react with vinegar, but the membrane slows the reaction by weeks, and the finished preparation will be weaker. Step 2. Combine with vinegar. You need a natural vinegar with 5 to 7% acidity. Plain white distilled vinegar works perfectly. Apple cider vinegar works. Brown rice vinegar works. Do not use balsamic vinegar, flavored vinegars, or anything with added sugar. Combine in a 1 to 10 ratio by weight. 1 part crushed eggshell to 10 parts vinegar. 50 grams of crushed shell in 500 milliliters of vinegar is more than enough. Step 3. Ferment. Pour the mixture into a clean glass mason jar. Cover the mouth with cheesecloth or a paper towel, secured with a rubber band. Do not seal the jar with a metal lid. You'll see vigorous bubbling within a minute of pouring. That is the acetic acid reacting with the calcium carbonate, releasing carbon dioxide. A sealed jar will pressurize and can crack. Set the jar in a quiet, dark cabinet at room temperature, anywhere from 65 to 75 degrees Fahrenheit. Wait between 5 and 20 days. The reaction is finished when the bubbling stops completely and the mixture goes still. The finished liquid will be pale gold, faintly cloudy. Strain through cheesecloth into a clean glass bottle. Cap loosely. Stored cool and dark, finished water-soluble calcium keeps for over a year. Step 4. Apply. Dilute at exactly 1 teaspoon per gallon of dechlorinated water. Not 2, not 3, 1. Stronger is not better. Stronger will burn the leaves. If your tap water is chlorinated, fill a pitcher and let it sit uncovered on the counter for 24 hours. The chlorine evaporates. Or use rainwater, well water, or filtered water. Spray the diluted solution onto the leaves and fruit. 3 applications, spaced 1 week apart. The first at first flower, the second at small green fruit, the third at fruit expansion. I need to be honest with you about something the bottled CalMag sellers will never put on their label. This preparation will burn your plant if you misuse it. 1. Do not exceed 1 teaspoon per gallon. The residual acetic acid will burn the waxy cuticle off your tomato leaves and brown them within 48 hours. 2. Do not spray in the heat of the day. Spraying acidulated water onto leaves in direct midday sun above 85 degrees will cause leaf scorch. 3. This preparation prevents blossom end rot. It does not reverse it. A tomato that has already developed the black sunken patch will not heal. 2 summers ago, a home gardener lost roughly 60% of her harvest to blossom end rot. The summer before that, she had spent over $400 on bottled products. The following spring, she ran the recipe in this video. Total cost, roughly $1.20 in vinegar. She was harvesting 41 Cherokee purples off 2 plants. 0 losses. $400 the year before. $1.20 that year. The math doesn't work anymore. It hasn't worked for 130 years. The Italian women of Acerra knew this. They had a clay bowl, a handful of eggshells, and a memory passed mother to daughter for 100 generations. The Korean grandmothers knew it. Cho Han Kyu learned everything modern agronomy had to teach him, and then chose the clay jar over the textbook. The University of Hawaii took until the year 2003 to publish the peer-reviewed paper that confirmed what the women of Acerra had known in 1887. 130 years for science to catch up. So tell me in the comments, where are you starting? Team Heirloom Rescue. You've got a tomato patch right now, and this is the intervention you're going to run this week. Team Container Grower. You're growing on a patio, a balcony, a deck, and you've been losing every season to a problem you didn't have the vocabulary for until today. Team Brand New Bed. You're planting tomatoes for the first time this spring, and you're going to start with this preparation already in your pantry. Drop the name in the comments. If this surprised you, share it with one gardener in your life. Subscribe, where every week we pull the old, real, almost forgotten ways of growing food back into the sunlight. Trust your kitchen.